Welcome to Module 6, Lesson 12, Unique Triangles. Two sides and a non-included angle. Here we go. We're going to continue with our unique triangle mode here, and we'll stay in this and determine what conditions or sub-conditions lead to unique triangles and which do not. Okay, so let's continue. Here we go. Here's our exploratory challenge. Okay, so again, getting our tools out. Please get out your tools. Of course, that means protractor, rulers, pencils, whatever else you need to draw the triangle ABC in the space below. Okay, in your space on your quite a bit of space in your binder, provided that AB equals 5 centimeters, BC equals 3 centimeters, and angle A equals 30 degrees. Okay, so continue with the rest of the problem as you work on your drawing. Okay, so what that means, there are questions that'll be asked, A, B, C, D, E, F, and they're all relate to this first part of the exploratory challenge. So go ahead and do that, and come on back, and we'll check it together. Okay, so let's go ahead and here's what I drew. Here's my triangle. As you could see, it is non-resolved or unresolved triangle because there are some issues, and I'm hopeful that you had the same issues. But anyway, I'm going to go over. I'm just going to read these questions here. You're not going to see them in front of you, but just take a look at them in your binder. Hopefully, you've answered all those A through F questions. So the first question is, what is the relationship between the given parts? And that's parts of triangle ABC. That's a really hard question to answer, and I just don't understand sometimes what they're actually looking for. But it's, what we have here, the relationship, truly this is not a relationship statement to me, but what they have as an answer here is that two sides and a non-included angle are provided. Okay, now I don't see how that is a relationship. Non-included angle are provided. So if you struggle with that question, I understand. That was question A. I understand the issue there, okay? Because I don't see that there's any real relationship. It's just maybe they could have asked you what conditions were given you, okay? And the conditions were two sides at a non-included angle, okay, were provided, all right? So B asks here, which parts of the triangle can be drawn without difficulty, and what makes this drawing challenging? Okay, well, those parts, of course, without difficulty were our 30-degree angle here. Okay, all right, and of course I can draw this line real easy. AB was easy to draw. Okay, right here, AB. My 30-degree angle was easy to draw, and beyond that, that was it. Okay, because that's what I was given. Okay, I was given that side. I was given this 3 centimeter side, but it's difficult to draw that 3 centimeter. I guess that's it's the challenging part, because I don't know my angle here. I don't know my angle B. All right, this is my question. I was not given that angle, therefore I don't know if it's 3 centimeters this way or 3 centimeters here. Okay, so I mean it could be it could be several different things, and I wasn't given this either, AC, length of AC. So yeah, this was a very, very difficult triangle to draw. So C here asks, well, it says here, a ruler and compass are instrumental in determining where C is located. Okay, and I guess they're just giving you little points here. It says, even though the length of segment AC is unknown, right? I talked about that right here. Okay, extend the ray AC in anticipation of the intersection of the segment BC, okay, which we did. Okay, we extended AC out in anticipation of where it was going to be intersected. Okay, draw segment BC with lengths 3 centimeters away from the drawing of the triangle. Okay, and then adjust your compass to the length of BC. So what they're saying is we could indeed actually do this and draw a circle with center B and a radius equal to BC, or 3 centimeters. Okay, so let's go ahead and give that a whirl. Okay, so let's go ahead and look at look at this process here that they're giving us in C, bit by bit. Okay, so it says here that even though, and this is the magic of the compass, I got to tell you, and circles again coming through here. Even though the length of segment AC is unknown, okay, we just extended it out, and that's what I told you I had done. Just extended it out there, okay, just anticipation of an intersection, okay. So then I went ahead and drew my little 3 centimeters away from the triangle here. So I just, and this could be any way. I mean, could have been this way, it could have been this way, it could have been this way. I don't really even need to do it because I'm going to use my protractor anyway. I mean, my compass to help me out. Okay, so I went ahead and did that, and that was this right here. Draw the segment BC 3 centimeters away from the drawing of the triangle. Okay, and then adjust your compass. Okay, so I went ahead and did that, and I have my compass here, and you can see it's set for 3 centimeters right there, as you can see right there, 3 centimeters. Okay, from right there, and I'm making now, of course, point B the center. All right, the center. So so I adjusted my compass here. Have my compass adjusted. This is where my my pencil point. I'm not sure which one you guys are using, but I like this one. My pencil point is going to go in there, as you know, and then I'm going to draw a circle with the center B and a radius equal to BC, or 3 centimeters. Okay, and when I do that, boom, boom, come up with that. Okay, excuse me, and let me go ahead and erase all this other stuff here. Okay, so there we go. I have my circle drawn. And now I can answer question D here, because D asks me, how many intersections does the circle make with segment AC? Okay, how many does it make? And we can see that it actually, actually I don't want to answer that yet. Okay, yeah, it makes 2. You can see where it intersects in 2 different places. So right here could be point C, or right here could be point C. All right, so how many intersections? It makes 2, and you might have done this already. Each intersection represents a possible location for the vertex C. Okay, so C can be possibly located here, or it could be here. Okay, and then part E here says complete the drawing of triangle ABC. And if I do complete the drawing of triangle ABC, you can see I have still have two possibilities of ABC. Triangle ABC could be this one here. Okay, that works with the conditions given to me. This one also works. Okay, and so indeed we've actually drawn here 2 triangles here. We can call this C1. This is C2 here, 2 possibilities here. So, I'm not exactly sure about this question, though, but it says, did the results of your drawing differ from your prediction? I don't remember asking you to predict, and I don't remember seeing anywhere in my notes to ask you to predict what it would look like. But, anyway, and I don't actually see that we've actually drawn just one ABC, because we still are very unclear as to which one they were intending us to draw. And of course, they may not have been intending us to draw one or the other, but just to show us how some conditions vary and how some conditions don't indeed have enough information. But let's go ahead and pursue this further, and let's go ahead and do this next one here. And we have number 2, okay? And number 2, it asks us to now attempt to draw Let me erase all some of this here. Okay. Now attempt to draw triangle DEF in the space below, okay, on your binder, provided, here we go, here are our conditions now, provided that DE equals 5 centimeters, EF equals 3 centimeters, and angle F equals 90 degrees. So continue with the rest of the problem as you work on your drawing, okay, and that is exactly like we did before, okay, and hopefully you will be able to do it a little bit more adeptly, and so will I, using what we know now. Okay, so question A asks us here, how are these conditions different? Oh, hold on a second, I haven't actually shown you the original one here. And let me go back to this here. Okay, so attempt to draw DEF, and I did, and here's what I came up with. You probably came up with the same. Again, I could easily draw my 3 centimeters here from between E and F, and this angle is very easy to draw because it's a right angle, okay, 90 degrees. Okay, so yeah, so that's what that looked like, and do this in the right order here. Now, A asks you here, how are these conditions different from those in exercise 1? And do you think the criteria will determine a unique triangle? Okay, so how are they different? Well, in exercise 1, and I'm not sure if you'll recognize this, and it's okay if you didn't, because that's what I'm here for. But if you might notice in exercise 1, you were given, again, given one side, not given the other, given one angle, and the angle you were given here, actually you were given one side you couldn't place, but the angle you were given here, what is very special about that angle? If you remember, it was 30 degrees. Well, that angle was an acute angle, okay, and an acute angle, as you know, is any angle that is less than 90 degrees, okay? So an acute angle is going to be, that is wrongly there, this acute angle is less than 90 degrees, okay? Therefore, that's that. Now, the angle we were given, this time, the second time around, exercise 2, was a 90-degree angle, as you can see right here. Okay, so it is not acute, it's a right angle, okay? Therefore, it may make a difference, I'm not sure. You probably are sure by now because maybe you've actually figured it out already. These conditions may or may not determine a unique triangle, or they may just be the same. It may end up being the same idea, okay? That's what I would predict. And hopefully you're getting used to this next question. What is the relationship between the given parts, triangle DEF? Of course, 2 sides and a non-included angle are provided. Okay, so we have 2 sides and a non-included angle. All right, so same as before. All right, non-included angle. And if you were doing this as you went along, you would have answered this question. Describe how you will determine the position of DE, okay, of line segment DE. And again, we're trying to, this is the line segment here, we're trying to create this one right there, okay, because this would be D somewhere. We don't know exactly where, maybe, or maybe not, we're not sure. But hopefully you said you would go ahead and use your compass and adjust your compass to 5 centimeters. That's what we had right there, and then go ahead and draw your circle, and yeah, just like we did before. Let's see what happens when I did that. Okay, well here is what happened. Here's what I came up with after I made my circle. 5 centimeters outside of, away from point E, okay, and used point E as my center, okay, and I made that circle and come up with that. So the question, the big question, the question of the lesson here is, how many intersections does this circle make with FE? Of course, FE, is that right? Make with, actually would be DF, wouldn't it? Yeah, that is not correct here. This should be DF, huh? DF, okay, right there. All right, I hope that didn't confuse you. It may have, but anyway, because this would be DF right here, and it makes only one, and there it is right there. Okay, right there, DF, only one. Okay, so what does this mean? If you go ahead and complete the drawing of triangle DEF, which it asks us to do in letter E, okay, and we're going to answer this question, how is this different than the outcome that we had from triangle ABC? How is this different? Okay, if we go ahead and draw our line and complete our triangle right here, there we go. And of course, the way it differs, which is the question here in E, well, of course, it differs in that now we have one point where it intersects. Okay, therefore there is clearly one triangle to be drawn, whereas before, if we remember this one here, if we look at our one from before, let me go find that, and there it is right there. Remember, we had possibilities of one or two different triangles could have been drawn. Okay, here A, B, C, or A, B, C. Okay, so two different possibilities, whereas now we have only one, and here is our D now. Okay, D, E, F. Alrighty, and let's see, did your results differ from your prediction? Again, I don't know, did you predict? I'm not sure. I don't remember asking you, sorry. But here we go, let's go to number 3. Alright, so now we're going to have you attempt to draw triangle JKL, provided KL equals 8 centimeters, KJ equals 4 centimeters, and angle J is 120 degrees. Okay, so go ahead and use those conditions and just go from soup to nuts. There's no questions to ask, to answer. Just use what you drew in exercises 1 and 2 to complete the full drawing. Just go ahead and do it all. Okay, well, I'll show you my steps here and see if yours looks like mine. Here we go. First step right there, and yeah, I had the angle that I was given, 120 degrees, and of course I had my my included line there was given, and I drew that as well at 4 centimeters. That's right, 4 centimeters. Okay. Next, I took out my protractor, my compass, and I set it to 8 centimeters using K as my center, and drew my circle, which went way outside of my piece of paper there. I'm not sure where you drew your J, K, and whatever, but as far as mine was, you can see what happened there. Probably should have drawn it a different way. And yeah, and you can see right there that when I do finish my triangle, it is unique. There's only one place where it intersects, that my circle intersects with my JL, and therefore I can safely put my L right there. Okay, so review the conditions, it says here in number 4, provided for each of the 3 triangles in the exploratory challenge, and discuss the uniqueness of the resulting drawing in each case. Well, we noticed that all included two sides and a non-included angle. Okay, so all three scenarios in this exploratory challenge. Okay, now angle ABC's angle was acute. Angle DEF was 90 degrees, and angle JKL was obtuse. So if you notice something there, and again, you remember what obtuse means. Obtuse means greater than 90 degrees. Okay, that's obtuse. So when we had the angle at 90 degrees and when it was obtuse, we had unique triangles drawn. Okay, so we could take a look. We have one. So this is our last one, which was JKL. You saw there was one intersection, the circle with the segment. Okay, and then we had as well in DEF also intersected in one place only. But as we noticed in ABC, the first one, we had two intersections. Our circle that we drew intersected in two different places, which meant that it was not unique. Those circumstances or conditions did not yield a unique triangle. Okay, so in summary here, we consider a triangle correspondence. If you consider triangle correspondence, triangle ABC compared to triangle XYZ, that corresponds to two pairs of equal sides and one pair of equal non-included angles. If the triangles are not identical, then triangle ABC can be made to be identical to triangle XYZ by swinging the appropriate side along the path of a circle with a radius length of that side. And that is just what we're doing this entire lesson here, using our circle to draw a path and then find our point. A triangle drawn under the condition of two sides and a non-included angle. And here's the main point here. A triangle drawn under conditions of two sides and a non-included angle, which all of these were, where the angle is 90 degrees or greater, creates a unique triangle. Okay, creates a new triangle. If you have less than 90 degrees, you will not be creating a unique triangle because you will find that you can create a circle off of those given sides and angle, and it will intersect in more than one location. Okay, so that is our rule right there. Two sides and a non-included angle. The angle has to be 90 degrees or greater, okay, to create a unique triangle. Okay? All right, so go ahead and finish up your problem set, and see you next lesson.